Hi students, in this video we're going to talk about measures of center, which is section 3.1 in your text. By the end of this video, you will be able to develop an ability to measure the center of data by finding mean, median, mode, and mid-range. Those are our measures of center. And also you should be able to determine whether an outlier has a substantial effect on the mean and the median. Now you have guided notes you can access to follow along with this video. They are in this week's folder in Blackboard. Now, what are measures of center? Well, they are values at the middle of a set of data. So there are different ways that we can measure the middle of our data. The measures of center that we're going to look at in this section are mean, median, mode, and mid-range. And as you can see here, we're starting with the arithmetic mean. Now, in your everyday human speak non-statistics terms, you might call that the average. In our statistics course, we're going to be discouraged from actually calling it the average, even though that's what we know it as, because in statistics, there's actually more than one way we can measure the average. There's more than one type of average. So what you used to call average, now you're going to call it arithmetic mean, or you can simply say mean. And for a sample, we call the mean x bar. X with this line over it, x bar. And for a population, we call the mean mu, and we use this funny Greek letter. We'll be using the terms x bar and mu throughout the course, so you'll want to get familiar with them. So the formula for mean is basically the same for the sample and the population. You're going to take the sum of your x values divided by your number of x values. Simply put, the sum of the items divided by the number of items. So when you look at this formula, that funny looking E, it really means the sum of, or it means add up all those values of X. Some features of the mean are that the sample mean is drawn from the same population tend to vary less than other measures of center. The sample mean uses all data values. Something that we don't like so much, or a disadvantage of the mean, is it is not considered a resistant measure of center. What does that mean? It's heavily impacted by outliers. Here I have some sample data, 13, 15, 11, 8, and 12. We're going to find the mean of that data. So what we'll do is we'll add up all of the items, 13 plus 15 plus 11 plus 8 plus 12, and we'll divide by the number of pieces of data, or the number of items, 1, 2, 3, 4, 5. And we get the sum of our items is 59 divided by 5, or 11.8. So the mean of the data, the sample data, is 11.8. Another measure of center we can explore is the median. The median is the middle value when you arrange your data from smallest to largest, which is called ascending order. So how do we find the median? We arrange our data in ascending order, and then there are two different processes. If there are an odd number of data items, then the median is going to be the number located in the exact middle of the list. If there are an even number of data items, the median is found by computing the mean of the two middle numbers, because you'll be divided into two groups and there's no exact middle value. Some features of the median. It's often denoted by X with a funny line over it called a tilde. So we call the median X tilde, you can see here. And it's considered a resistant measure of center because it's not impacted by outliers. Well, that makes sense because the median is only considering the middle values. Let's do an example using our sample data from the previous question where we found the mean. This time we'll find the median. So we have 13, 15, 11, 8, and 12. First step, put them in order. To reorder the numbers, we have 8, 11, 12, 13, and 15. There are 5 data items. So to find the middle, we could just count because it's a small number. But if you have a larger number, you can take the number of items and divide by 2. And here we get 2.5. So there's a decimal there, so I'm going to round up. The middle piece of data is data item number 3. So I'll count 1, 2, 3. The median, X tilde, is 12. Let's try this again, but add another item to our data set so we have an even number of data items. I have 8, 11, 12, 13, 15, and we'll say 48 for our last data item. So we have 6 data items, so I can take the number 6 and divide it by 2. So the middle is going to be 3n, so 1, 2, 3. That divides our data in half. I know we could have counted that, but I think it's helpful to know this process for when you have a larger amount of data. So what I'm going to do is I'm going to compute the mean of the two middle numbers. That would be 12 and 13. So 12 plus 13 divided by 2 gives me 12.5. So the median, or x tilde, for this data set is 12.5. Our next measure of center is the mode, which is the most frequently occurring data value. It's possible to have any amount of modes. It could be 0, 1, 2, 5, or more. It's the only measure of central tendency that can be used with nominal data. Something could be multimodal, having more than two modes, or if something has two modes exactly, you would call it bimodal. Looking at our original data set of 13, 15, 11, 8, and 12, you can see that there's nothing repeating. So we would say there's no mode. Looking at the data set of 13, 15, 11, 8, 12, 12, and 11, you can see that 12 repeats once, but also 11 repeats. So we would say that this is bimodal. In this final example, we can see that we have 13 listed 3 times, but we also have 12 listed more than once. 12 is listed twice. We would not say that this is bimodal or multimodal. We would simply just say that 13 is the mode here, because 13 occurs the most frequently. Our final measure of center is the mid-range, the value midway between the maximum and minimum values in the original data set. It's sensitive to extremes and it's rarely used. The mid-range equals the maximum plus the minimum value divided by 2. For our data, 13, 15, 11, 8, and 12, our maximum value is 15. Our minimum value is 8. So we're going to do 8 plus 15 divided by 2. We'll get 23 over 2, or mid-range of 11.5. Now that we know our measures of center, let's talk about a couple of other general rules. Round-off rules. For the mean, median, mode, mid-range, and variation also, we carry out one more decimal place than is present in the original data set. For the mode, leave values as is without rounding. Why? Because you're making no calculations. And try to avoid rounding in the middle of a problem, because the more you round in the middle of a calculation, the more your final calculation will be off from the actual value it should be. And finally, just a reminder, a statistic is resistant if the presence of extreme values, also known as outliers, does not cause it to change very much. Now that we've practiced together, what I'd like you to do is on page 2 and 3 of your guided notes, complete examples 1 to 5. Pause the video and complete examples 1 to 5 on page 2 and 3. Answers will appear soon for you to check. Take a moment to check your answers for 1, 2, and 3. For 1, we get a mean of 30.74 megabits per second. For 2, we get a median of 23.1 megabits per second. For 3, we get a median of 23.8 megabits per second and a mean of 29.7 megabits per second. For number 4, A has one mode, 7. B has no mode. C is multimodal with modes at 1, 4, and 9. D has one mode, 12, and E is bimodal with 0 and 1 time for mode. Number 5, we find the mid-range of our data to be 34.85 megabits per second. Tune into the video on means for frequency distributions and weighted means in order to complete your guided notes.